Okay, ladies and gentlemen, this assignment will help you do level 4 work for our Pythagorean theorem proficiency scale. So the first thing that I want you to do is list all of your perfect squares in these boxes. So you can put one number in each box. So take a minute and do that and then come back. So the numbers, your perfect square numbers are 1 because 1 times 1 is 1, 4 because 2 times 2 is 4, and then 9, and we should hopefully have all of these memorized by now. So 36, 49, oh I forgot 64, 81, 100, 121, and 144. So then what I would like for you to do is pause the video and check your answers for A and B, and we'll talk about C when we come back. So the distance between Old Navy and Chick-fil-A, if you drew your right triangle, you would have found that you had a triangle that was 10 by 1. So 10 squared plus 1 squared gives you 101, and then you'd square root that. The distance from Chick-fil-A to Best Buy, that was kind of an easier one because I didn't have to draw a right triangle. I could have just counted the distance along this line, which would have been 4. So that kind of brings us to the idea of letter C, as when we had to find the distance between Old Navy and Chick-fil-A, we had to use the Pythagorean theorem to find that distance. But with Chick-fil-A and Best Buy, we did not because it was just a straight line, or a straight vertical line. So now, if you look at letter D, this kind of gets us into the level 4 work. We want to actually create a distance of square root of 29. Now, the square root of 29 is an irrational number, so the only way that we're going to be able to draw something that's exactly the square root of 29 long is to use the Pythagorean theorem. So the idea being, we want to create a triangle whose hypotenuse is the square root of 29. So if we want to do that, if we know that this is going to be the square root of 29, then the area of that square off of the hypotenuse would have to be 29. So then you're asking yourself, okay, well, what would these areas have to be so that they add to 29? And then that's when this is going to be helpful to you up here. Look through here and find two numbers, two of your perfect square numbers, that if you added them together would be 29. So that would be 4 and 25. So that would mean one of your areas would have to be 25 and the other would have to be 4. And then therefore those side lengths, this side length would be 5 and this side length would be 2. So to make a distance that is square root of 29 away from your Starbucks, you can draw any 5 by 2 triangle. So you could count up 1, 2, 3, 4, 5 and over 2. You could put it there. You could have also counted up 2 and gone to the, or counted up 5 and gone to the left 2. You could have counted over 5 and then up 2. So there were several different ways that you could have made a distance of square root of 29. And that kind of answers letter E for us as well. If you look at letter F, we're asked to make an orange leaf that's 5 units away from Dairy Queen. Well, this is not an irrational number. It's a rational number. So that'll be like making a distance like the Chick-fil-A and Best Buy distance. I just have to count 5 in any direction from the Dairy Queen. So if I go to Dairy Queen, I could go up or down 5. I could go over 5. I could go up 5. And I could put that distance in. And then that's all 5. So letter G, how are constructing the links in these two instances different? Well, when I'm trying to make an irrational length, I'm going to have to undo or kind of recreate this Pythagorean theorem model to help us do that. So if you flip your paper over, let's see if we can construct a distance of square root of 90. So that's an irrational number. So you'll want to look at the list of perfect squares on the other side and see if you can come up with what two numbers will add to get 90. So hopefully you were able to see that the perfect squares of 89 and 9 will add up to 90. Now that doesn't mean we draw a triangle that's 81 by 9. Remember, those represent areas of squares. So So then we have to square root these values to find the actual side lengths. So the side lengths of your triangle should be 9 and 3. So from the school, you can go, you need to make a 9 by 3 triangle. So you could go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and you could go to the right 3, or you could go to the left 3. Those are both the same. Those are both the square root of 90 away from the school. You could have also counted over 9 and down 3, or over 9 and up 3, and that would all be the same. So now what I want you to do is pause the video and see if you can find or create the distances for A, or for B, C, and D. Okay, so your answers should be for this one. You should have realized that the perfect square is 116. We'll add up to 116. So the distance, or the triangle that you would have to create, would be a 10 by 4. So anywhere from the grocery store, either up over 10 and down 4, or down 10 and over 4 would be fine. To find the square root of 68, you would have done 64 and 4. So you would have had to create an 8 by 2 triangle starting from the mall. So you could have gone over 8, down 2, or over 8, up 2, or up 8 and over 2. And then the police station, to get the square root of 40, you would need to have 36 and 4. So you need to create a 6 by 2 triangle. And you need to put that from the gas station, and we want it to be on the same street as the grocery store. So that's kind of forcing us to go up so that we're on the same side of, or the same street as the grocery store. So if we look, 1, 2, 3, 4, 5, 6 puts us on the same street as the grocery store. So and then you'd have to go over 2. So you could either put it there, or you could put it here. And those would be the 2 places that the police station could go. I'm gonna go ahead and stop this video here. You'll have the chance to look at an answer key to check your answers for number 4 when you're finished. But yeah, if you can create these links and draw them on the coordinate grid, that is going to be the level 4 task for this proficiency scale. If you have questions, find Ms. Fike or Ms. Cobell.